Hey everyone, my name is Noorain. You can call me your tech bot. At Xavier, I lead the product team for Kubernetes and platform engineering. Basically, my job is to build solutions around Kubernetes to simplify the adoption and usage of, again, Kubernetes and the cloud for our customers. Today in this talk, I'm going to be talking about policy management and more specifically how you can shift policy management left with OPA Gatekeeper. But before we start, I want to just set some context, right? So Zebia is a services company. So we work with, at a certain scale of customers, right? So I think to just give you an idea, 4 of the top 10 private banks in India are built. I mean, their channels are built by Xavier. We're even setting up some private banks in the APAC region. And not just that, even 4 of the top 10 airlines of the world are serviced by Xavier. So what I'm trying to say is that our customers, and in fact, Xavier is running mission critical applications. They are high throughput. We are handling thousands of requests per minute. And these industries, as you may notice, are highly regulated. So downtime is not an option. Right. So we did some research, we did some internal introspection, and we figured out some causes that leads to downtime in production applications. And I mean, there's a whole list of it. I mean, we can go on, and there can be a complete talk on this. But the big ones that we encountered were surprisingly misconfigurations, and more specifically, misconfigurations with Kubernetes, right? Now, I know this might sound odd, like after all, Kubernetes, I mean, it's just a Helm chart that we need to deploy at the end of the day when we're working with Kubernetes, right? So that was a bit surprising, but yeah, misconfiguration is a big piece there. And also advanced access control. So access control in Kubernetes isn't all that great. So yeah. So most of our workloads run on Kubernetes. Most of our customers' workloads run on Kubernetes. Now, like I said, the perception that vanilla Kubernetes is enough isn't true anymore, right? In production workloads, when you're working with enterprise customers, there's a lot more to Kubernetes than just what comes out of the box, right? There's an entire ecosystem of tools being built around Kubernetes, what we like to call the Kubernetes companions. So today, I can configure and provision my ALB, my load balancer, via Kubernetes, right? Not just that, we also deploy infrastructure, including databases and Kubernetes clusters itself from within Kubernetes. And it's not just infrastructure that I'm talking about, even your observability stack, your logging data, your metrics, your tracing data, all that is configured via Kubernetes resources today. So the notion of just deploying your application in Kubernetes goes way beyond just the application itself. It's starting to percolate into infrastructure. It's starting to percolate with observability, alerting, and even security, right? So it's not just, configuring Kubernetes is not just about applications anymore. And as you may see, this makes ops a lot easier for us, but it makes configuration a nightmare. Right? Working with all these resources and making sure that all these different tools are working well with each other is a big problem. And that's where most of the downtime, not most, but a big chunk of the downtime originates from. So I just want to take some examples of certain misconfiguration, which leads to open attack vectors or downtime. So again, these are just examples, right? Like making sure that you're running as a non-root user, making sure that privilege escalation is not allowed. Making sure that even your probes are in place. I mean, we often keep forgetting it. Maybe we want specific kind of probes, like we have a policy around that only HTTP probes should be used. We don't want to use TCP probes because they are not that effective in detecting errors, right? Not just that, we can even deal with supply chain attacks using proper resource configuration. Like a lot of the DevSecOps world is facing this big problem with supply chain attacks, right? One way to combat it in one aspect is by making sure that the images, the container images that we build and we push are signed and verified. And only the vetted images are being deployed in our cluster, right? So having policies around which images are allowed, all of this can cause problems. And leaving all the responsibility of making sure these configurations are done to the developers might not be enough in most cases. But it's not just single resource configurations, right? It's not just making sure we've configured the deployment object right. The real problem stems from the ecosystem around Kubernetes. We're talking about multi-resource configuration. The easiest example would be, deployments working with HPAs, right? So making sure all our stateless deployments in the production environment are backed by an HPA, by a horizontal pod autoscaler, right? And also, if we have an HPA in place, make sure that the replicas field is not set in deployments, because that causes problems, right? So now our policies are going beyond a single resource. We are talking about how different kinds of resources are kind of playing together, right? Another example which I love to take is ingress. So if you're working with, if you worked with EKS and ALB, or if you worked with any ingress controllers before, you can expose your services to the internet using an ingress object. But you might not want to do that, right? You might want to expose your services just to a private network. You want to make sure that the subnets you are exposing your services to are private. They are not exposed to the internet. And you want to control that. Or maybe you want to expose a service directly, but you want to make sure that, no two services are exposed on the same host, because that's a conflict and, the behavior would be unknown in that case. Or maybe you want to even whitelist which services can even be exposed in the first place. Maybe I have a set of internal services which are internal to my cluster, and I don't want external services on my front end to even access them. All that requires policies. And finally, my favorite example, because we are an Istio shop, and Istio is really complicated when it comes to configure it, right? So at Xebia, we use a zero trust principle, wherein no services is allowed to talk to each other unless explicitly given access to it. So if I deploy something, nobody will be able to talk to it. So we have to set up authorization policies here. So making sure that, we have an authorization policies being deployed alongside of our deployment, which have a port exposed, right? Because otherwise we'll just lock it out and it wouldn't be able to talk to anybody. So these kind of misconfigurations is something which we're seeing that are growing, because the tools around Kubernetes are evolving rapidly. Istio, your ingress controllers, they're all moving really fast, and making sure that our Helm charts or our DevOps teams or our developer teams can keep up with it is difficult. So you need policies, or you need some framework, some governance model around which you can restrict what is allowed, what is not allowed, but at the same time, not restrict them to the point that they do not have control of what they're deploying anymore, right? That's where OPA Gatekeeper comes in. So at Xebia, we started evaluating Gatekeeper a little more than a year back. It's almost been 2 years, actually. So we've been using OPA Gatekeeper since 2 years in production now. And it's doing really well for us. So how it works, right? How does OPA Gatekeeper works? I won't be spending too much time here, but let's just cover the basics, right? So you have your developer. That's me. I'm the cute guy. Your developer wants to apply resources or, patch resources to Kubernetes. And it's not always your developer. It could be your admin. It could be your CD pipeline. It could be via Helm charts. It could be using kubectl directly. No matter what way you want to interact with Kubernetes, it's always going to go through the Kubernetes API, right? All your tools will be talking to Kubernetes API directly or indirectly. Now, OPA Gatekeeper has taken a smarter approach. It understands that the number of access points to Kubernetes are insane. Anybody can talk to Kubernetes in so many different ways, right? So what OPA Gatekeeper has done is it has made an admission controller. What that means is it can intercept all API calls which are made to the Kube API. So if I want to deploy a deployment or a service to Kubernetes, so let's say using kubectl apply, the request, once it hits the Kube API, is going to first go to OPA Gatekeeper. So OPA Gatekeeper will validate whether things are right or wrong, and will give a true or false kind of a reply, right? Whether what action I'm trying to take is allowed or not. If it's not, it's going to throw an error straight up. If it is allowed, it will let it go through. So this means that the policy or the governance model I set up using OPA Gatekeeper are universal. Anybody or any mechanisms to talk to the Kubernetes API will be protected under this. And this is one of the selling points which we absolutely love, because having discipline throughout the organization, even in your development clusters, even in your staging clusters, sometimes gets difficult, right? You need some flexibility around the access points. And OPA Gatekeeper working on the API layer of Kubernetes really makes things much simpler for us to manage. So, okay, that was a lot of words which I just said, right? And if you're like me, you're just focusing on the cute guys. So let's take things, let's take things for a spin and see how OPA Gatekeeper really works. Okay, so I hope my code editor is visible. So in OPA Gatekeeper, we define policy templates. This is used using some language called Rego. It may seem a little intimidating at first, but don't really get scared by it. I'm not going to cover what Rego is or how it works or anything, but just remember this, that in OPA, you get this custom language to write policies in, which is called Rego, which is this right here. And there are a bunch of pre-populated policies which ship with OPA Gatekeeper out of the box. So you don't really need to be a Rego pundit to work with it. So you have templates which have Rego policies, and they accept a few variables. So here I have a template, a constraint template to disallow the tags to be deployed, right? So, I mean, I want to have a policy that the latest tag cannot be used in my images, in my container images. I want to make sure that only proper tagged images are deployed. Fair enough? Great. So once you've made a template, you then make your policy. So here I'm saying that, hey, I have this policy. I want it to run with deployments and stateful sets and even pods. I mean, you could go ahead and, even make it work for daemon sets. I mean, that's not the point. And finally, I pass the parameters, right? The tags which I do not want to allow, which is the latest tag. Correct. Going over to my terminal, I've already applied both of them, but I'll just do it again just so that we're sure about it. Policy. Oops. Okay, that's it. So applying these policies are just how you would apply any other resource. It's just a Kubernetes object. Now the resource in question is this deployment file, right? So I'm trying to deploy Nginx, and I'm trying to use the latest image. And like my policy, you just saw my policy doesn't allow me to use the latest tag. So what will happen if I try to apply this instead? So let's try that. It gives me an error. So see, this is kubectl again, right? So the kube API itself is throwing an error saying that this deployment is not allowed because it's using a disallowed tag, which is Nginx latest. The disallowed tags are latest in this example, right? So my resource is just blocked. Now, even if this was my CD pipeline or anything of that sort, it would still be blocked. Now, if I correct this error, let's say I make it, some random image. I'm not sure if it really exists, but that's not the point. Let's apply it. Now it's created. Perfect. So that's the governance model. So again, the way I write my resources, it's not changing. I can still use kubectl. I can still use Helm. There's no problem there. It's just that my governance model is sitting behind the kube API and just making sure that everything works out of the box for me. So that's the demo. I hope you guys got some more clarity on what OPA is and how it works. But that's not enough. We're talking shifting left, right? We've got a big problem here. So if you're continuously deploying like what we do, or even if you have version releases or milestone-based releases or heavily regulated releases like what our customers usually have, is that you have your developer. That's me again. So you have a developer who's making changes to the dev branch or to the feature branches. You have your CI pipeline which works. We run those tests. We merge it in our main branch. And finally, we have the CD which kicks in, right? But OPA will come in only during the apply stage, right? When you're actually applying those resources to Kubernetes. And that doesn't happen until late in the entire pipeline. And it's too late, right? You want your feedback to be as quick as possible. In fact, it should be as soon as I check in code. So if I'm checking in some manifests, or I'm checking in some Helm values which are incorrect or are violating my governance policies, that feature branch should not be allowed to merge, right? That's the objective, because having everything to work only on kubectl apply is too late in the cycle. And unfortunately, that's where OPA works. Now, the thing is, there are some community tools like conftest you can use to, kind of shift left this entire policies. But the problem there is they require you to rewrite your policies. So a big problem with the OPA Gatekeeper community at this point is that we are not allowing checks, pre-active checks on the CI layer or on the UI layer, right? It only works during apply. And if we want to shift it left, we have to rewrite our policies again, which just duplicates the amount of work. And we work with more than 7,500 policies, at least in my organization. That's a lot of work. And I'm lazy. Like, that's me, right? I'm lazy. So let's look at another demo, right? I want to show you another capability of OPA itself, okay? Nothing fancy, OPA itself, which can help us solve this problem. So one thing I hid from you guys is that OPA is written in Go, okay? And my team is complete Go shop, and we love Go. So what we did was we included OPA as a library to solve the problem ourselves, okay? So what I'm doing now is, you can see, I'm picking up the Rego template, which we saw in the OPA, in the OPA template file, that Rego piece of string which was written there. I'm picking it up and compiling it myself using the OPA library, right? I'm picking up the policy for the parameters, which was the latest tag, right? And I'm picking up the parameters myself. I'm picking up the deployment file as well that we just saw. Let me make it an error as well. Let's make this latest so that we make sure that we have an error coming in. So I can just read it. This is just like a simple read. And finally, I can use the OPA library to evaluate the Rego and run the policies myself in my code, right? Now, okay, there is a little bit of boilerplate, which I'm, avoiding here, but all of this is on GitHub. I'll probably, send across a link as well. You can use that to check the code out yourself. But the idea is that my own API server or my own Go code or my own CLI can now run OPA policies for me and maintain the integrity of the files which you already created for OPA Gatekeeper. Okay, so how does this work? Simply compile the binary, give it a few seconds. Oh, it's done. Great, that's fast. And just run it. And you see, I'm getting the same violation that we got when we tried to apply it using kubectl. It's the same error, right? Your Nginx is trying to use a disallowed tag. The disallowed tag is the latest. That's great. This means now, if we just make a simple CLI, now this is oversimplified, but if we make a CLI, we will, at least in theory, be able to run the OPA checks on the CI layer. So whenever any code is trying to be merged from your feature branch to your main branch or to your trunk branches, you can now run your violation checks, which is shifting left the entire process of governance way ahead in the pipeline, right? And that's what we've done. Of course, you can take this code, extend it, play around with it yourself. But just to complete the demo, I'm going to make this correct and try to run the same command again. And it's looking good. Awesome. So that concludes, the entire presentation, which I had for OPA. But just one last thing, right? If you guys have been in this domain, you've probably heard of OPA Gatekeeper and also have heard of some of the alternatives like the tree and Kyverno. So when we were evaluating OPA Gatekeeper, we kind of evaluated this competition tools as well, right? These alternatives as well. And all of them are in the open community. We can just use them. It's great. So why OPA, right? Why did we zero in so heavily and invested so heavily in OPA Gatekeeper? First, the Rego language of OPA Gatekeeper, it's a language. it's not a YAML-based tool which we're using here. Neither is it just JSON schema, right? It's a complete language made from scratch for rules. And that gives us a lot of flexibility. I mean, all the rules which I spoke about, it is possible to write them in Rego. In fact, we've written them in Rego, right? Secondly, OPA Gatekeeper is not just about Kubernetes. OPA Gatekeeper is a subset of the bigger project or the umbrella project, which is OPA. And OPA is cross-functional. You've probably heard of you people using OPA for infrastructure checks as well. Terraform just added support for it in Terraform Cloud. You can even put OPA policies on your API gateway layer. So you can see if you learn Rego, which has a bit of a learning curve, you can technically use it across your tech stack, which is great. Because you learn it once, use it everywhere. Secondly, the entire OPA project is written in Go, which makes things extremely flexible. So there are a lot of pieces in OPA Gatekeeper which we do not like. The one thing, shifting left. Then there's the auditor which comes out of the box with OPA Gatekeeper. These are some problematic areas for us which we felt wasn't satisfying our needs. But since everything is available as a Go library, we can just write some code and extend it ourselves. And it just works out of the box. I mean, the documentation is great. The community is great. They're really helpful and it works. And the most important reason, I should have probably taken this up first, is at that time when we evaluated things, OPA Gatekeeper was the only policy management tool which supported the multi-resource use cases. So in OPA, like you saw in some of the examples, like I alluded to it, whenever you're applying a resource, OPA can perform policy checks based on existing resources in your cluster, right? So it's a multi-resource kind of policy checks, which is the core problem of what we saw was causing a lot of downtimes or was causing a lot of problems for us. So OPA Gatekeeper is great that way, right? It can work with multiple resources. So I hope you liked this presentation. I hope this was helpful. If you found this content to be helpful, you can follow me on YouTube. The channel name is Backstage with Architect. I keep posting content like this one. If you have questions for me, you can even put it on the chat, I guess. I'll try to answer it. You can reach out to me on Twitter. I'm your tech bot. Or just drop me a message on LinkedIn. Always there for you guys. Hope you guys enjoyed the session. Hope you guys enjoy the other speakers as well. And have a blast, guys. Have a great day. Thank you.